Hello guys, today's video is not about high voltage or high voltage equipment, but I will show you a design I made for a customer some couple of years ago. It is a GPS discipline NTP server with a real-time clock chip inside. The specs were, of course, as cheap as possible. He wanted it in 1 week, and he needed only 5 pieces. So, considering these specifications, no CNC machining was possible because of the time and the budget available. So this is a very good example on how do you use PCB boards to make front panels. I will show it to you in detail later, but this is one of them. And what I used for this design, which case I used, and why, and what is the inside. The sponsor of this video is PCBWay. I already, of course, opened it and took the PCBs outside. I made a panel for the panels, for the front panels. So this is the front, as you can see it here, like that. And this is the back panel. We'll see in a couple of moments. Great PCBs as always. Thank you, PCBWay. The second PCB is the base PCB itself. That's what is inside the box. I already marked them because the marking means that this should be the next ones to be taken to if another piece is necessary. 5 pieces is a very small count. So this was in a tight budget, but with the help of PCBWay and with the correct casings, this was not a problem at all. So a little more in-depth explanation. I kept it minimalistic because of the budget, so no display or any other fancy things. It's just a 12-volt power supply, external power supply, Woolward it's called, yeah. I wanted to use for the server, I planned from the beginning to use a Raspberry Pi, but due to the high price of the Raspberries, this was not an option. So for the first time for this project, this is the second time I went for this microcomputer, I used an Orange Pi, and it is an Orange Pi R1. Honestly, great stuff. Really, in my opinion, a Raspberry Pi killer. There are so many different flavors and so many different versions of it that everybody will find what he needs. This one is the Orange Pi R1. It has been used because of the 2 interfaces. It has 2 Ethernet interfaces, 100 megabits. And the good thing is, as you will see inside, that it has a lot of USB interfaces that I'm using, and they are broken out on the pins of the board itself. As for the rest, it is just an indicator of the pulse per second, GPS pulse per second, that comes from the receiver itself. That shows me that the receiver is in sync, in 3D fix, and a power. This is part of the booting sequence. When the whole thing starts up, we have some glare here. It's not really interesting, but we are already there. Here we can see the Orange Pi greeting. Again, here we can see the information that comes from the satellite receiver, the EMEA data. You can see the amount of satellites we are seeing already. Seeing 12 satellites. And above, you see the configuration of the NTP server itself. The PPS signal is the pulse per second signal that is delivered from the receiver, from the GPS receiver itself, that synchronizes that with high precision the time that is delivered by the serial port. The serial port is SAM. That means it is, you see that is a star that is selected, and the PPS is selected too. So the NTP server is completely synchronized. The local, what I added here, is the real-time clock. That is a fallback mechanism, that if everything else fails, the real-time clock will deliver the real-time clock chip that is on the board I developed. It will deliver the time. The problem is that like the older Raspberry Pis, the Orange Pi does not have a real-time clock on board. Therefore, it was necessary to add this additional RTC. It's connected through I2C to the Orange Pi, and it is battery backed and temperature compensated. Additionally, a script was written to synchronize every 10 seconds, I think, or every 30 seconds, 10 seconds, I think, the RTC with a local clock. So the system clock is always consistent. Or is it even 5 seconds? I don't know. It's quite some time ago. The idea was that a base system would be delivered to the customer that has the NTP server on it, a working NTP server, the scripts necessary to synchronize the clocks, and everything else would be changed and modified and adapted by the customer itself, but from his software department. So this is how it looks. The satellites. Everything that's over 30 is okay. The signal to noise ratio. So it's time to look inside. Okay, let's have a look on the box itself. The enclosure. It is an aluminum extruded enclosure. This thing is available at least on stock in silver like that, or in black. I had another design using a black one. Front PCB, one PCB for the front plate, second PCB for the backplane. The backplane or backplate, backplate is better, right? It just has a GPS and an SMA connector for the GPS antenna. I added a USB to serial bridge to the console port of the Orange Pi. So independent of network connectivity, it is always configurable. Here you can see which chip I'm using, CH340 from VGH. And I provisioned a place for another SMA or RP SMA, independent what is used, for an external Wi-Fi antenna. This need of course to be connected on the Orange Pi. This is because in one location the customer wanted the Wi-Fi connectivity too. So let's see how it's inside. I had to pause momentarily because I have only one hand left to do the things, and it's not to be opened with one hand. So this is how it's inside. The cooling pad is done like a sandwich because it's 10-12 millimeters high. You see the footprints of the components on the back plate, on the bottom side of the Orange Pi. That means here the complete enclosure is used as a heatsink, and this is very effective. Here we have the Orange Pi itself. The whole system is on a micro SD card. We start from left to right. Power supply connector and PTC thermistor as a fuse. Reverse protection polarity diode. TVS for overvoltage protection. The switch mode power supply with overvoltage protection. Grow bar on the outside. The USB to serial bridge that connects to the console board. Here you see the battery backup, and this is the chip I'm using. It's a thermally compensated chip with battery backup. The receiver itself, the GPS receiver, again, this is one of my designs that I made, so I can use any of these U-blox Neo series, what I want. Let's turn it around. Not much else to see, just the two LEDs, and that's it from inside. Again, this was only possible because of the fast turnaround of PCBWay. That is the sponsor of this video, the sponsor of the PCs used. Don't forget to go to their website, to visit their website. You will see there that there is not only PCBs that are orderable, but even CNC machining, 3D printing, and they even have a gift shop. So for now, this is how it looks. And the whole thing in operation again. It's already in sync. It has a 3D fix. That's the front. And let's see again the back connected. So, if you like what you see, if you like my videos, please press the like button and subscribe. This would help me a lot, so I can make more of these videos and show you more of stuff I've done and I will do. Cheers! Of course, I forgot something to say, that the design files, even the system itself, would be available on demand because it's already not disclosed anymore. I want to thank all my subscribers, my current and my future subscribers. Thank you guys. Cheers.